Precise measurements of a star's orbit prove Einstein right. Dr. Brad Tucker and I dive into this Talking Science Story of the Week.
Across Apple Podcasts, Spotify, Google Podcasts and YouTube, this is Talking Science with Dr. Brad Tucker and Matt Miller.
Alrighty, well, our next story of the week is a little bit calmer and quite cool. The Very Large Telescope in Chile has been precisely measuring a star's orbit around a black hole here in the Milky Way, and we've proven Einstein right yet again.
Yeah, this is a really cool project because this is talk about dedication. These are observations that have been going on for 3 decades now. And that is at the center of our galaxy, Sagittarius A star, the supermassive black hole that resides there. They've been tracing the motions of stars around that black hole. And as the instruments have gotten better and telescopes have gotten better, they get finer resolution. And they're able to precisely measure how the star is moving around the black hole and how that movement is influenced by the physics of the black hole, general relativity, something Einstein predicted and people have calculated solutions to. And a really cool effect, which is called essentially the precession, or the kind of the wobbling of the orbit, has been conclusively detected with one star in particular around this black hole.
And what does this prove for us?
So it's a really cool aspect of essentially orbits and Newtonian physics, Newton's laws versus Einstein's laws. What it says is that if you get closer to a source of relativity, essentially a black hole with the gravitational effects, what happens is the orbit isn't kind of a perfect constant elliptical orbit. You don't go in the same path, kind of like you think of us going around the sun. You slightly wobble around. So it's kind of like a top slightly wobbling. And so you're not going at the same spot every time. So it would be like if the Earth's orbit around the sun, which is slightly changing, eventually wobbles over time. So we're not really orbiting the same spot every time. Now, this effect was actually used on the orbit of Mercury. In fact, this was really the first tangible evidence of Einstein's laws when the orbit of Mercury, which has this precession because it's so close to the sun, was not calculated or predicted by Newton's laws, but Einstein's laws. So now this is the first time we've really seen it around another object and really around a black hole.
And when we think about the times that these people were living in, to come up with these theories, even Newton is wrong here in this instance, but to even think along these lines and to come up with these theories is just incredible. And to me, a simple podcast host, absolutely incredible and just impossible to fathom how that can just pop into their brain. You're one of these smart people, Brad. How does it happen?
Well, look, and this is what's called the Schwarzschild, orbit, which is Schwarzschild he did a lot of the work of black holes. And in Einstein's relativity, there are what we call solutions. There are ways of solving these equations in distinct instances. And one of them is the activity around black holes. Schwarzschild is called the Schwarzschild radius, what is essentially the boundary of the event horizon of a black hole, how big a black hole is. And so it's really amazing to come up with these solutions, literally in the true sense of this really obtuse equation, and have a solution to something that you don't even know if the physical thing exists, and you really have no way of thinking that it's ever going to be proven. This goes back to gravitational waves. Einstein, when he came up with this equation, said there would be ripples of gravitational waves, ripples of gravity through space. There will never be a way of proving this because it is so small, but hey, I'm still going to calculate it anyways because, maybe what if? Lo and behold, 98 years later, someone after building a telescope in LIGO was able to prove it. And in this case, after multiple telescope upgrades, someone was able to see this precise orbit that, it's mind-boggling to think that they were able to detect it.